As AI technology continues to advance, the training and inference costs of foundation models are decreasing. Enterprises across various industries are investing in foundation model training, driving a growing demand for more computing resources. However, enterprises face challenges such as lengthy construction and difficult physical capacity expansion when building private computing pools. In sectors like healthcare and finance, for example, foundation model training involves large amounts of sensitive data. So, raw data cannot be written to disk once it leaves enterprises. To address these issues, enterprises adopt a distributed training and inference solution. This approach relies on leasing computing resources rather than building computing pools. It reduces the investment in intelligent computing cards, speeds up AI application rollout, and enables flexible scaling of computing capacity. To ensure that sensitive data is not written to disk, the network must support training based on local storage and remote computing power through remote direct memory access. However, this type of training involves two pain points. First, packet loss leads to a loss of computing power. The large data transfers involved in training often cause traffic bursts. If the network cannot handle these bursts, data congestion or packet loss occurs. RDMA is sensitive to packet loss. Even a 0.01% packet loss rate can reduce training efficiency by 50%, and a 1% loss rate can nearly halt throughput entirely. This results in the intelligent computing center sitting idle while waiting for data, leading to a loss of computing power. Second, network congestion can easily spread, affecting the computing efficiency of multiple tasks. Long data transmission paths mean that any network congestion or faults result in slow status feedback using traditional backpressure technologies. This leads to widespread network congestion and affects the computing efficiency for multiple tasks. To address the packet loss issue in RDMA over the WAN, Huawei has introduced subscriber priority-based flow control technology. SPFC combines SRv6T policy and network slicing to ensure zero packet loss for RDMA-based transmission across thousands of kilometers of the WAN. SPFC provides the following two benefits. First, multi-tenant isolation. PFC divides an interface into 8 priority queues. Each queue can independently pause and resume traffic transmission, enabling differentiated control. SPFC further enhances PFC by providing multi-tenant isolation capabilities through network slicing. Services on an interface are first divided into different private lines using network slicing. Then, traffic of each tenant's private lines is allocated to different priority queues to achieve finer-grained traffic control. Tenant-level slicing and tenant-level precise flow control prevent service faults from spreading between tenants. Second, lossless WAN transmission. SPFC is deployed throughout the network, and the ingress node can send PFC messages. By leveraging traffic control based on device network synergy, network-level buffers absorb traffic bursts, ensuring lossless transmission of RDMA packets over the WAN. In this network setup, SPFC is deployed across the entire network. When traffic bursts occur for tenant 1, the device's buffer usage keeps increasing. Once the buffer usage hits the predefined backpressure threshold, the device sends SPFC backpressure packets to its upstream device. Upon receiving these packets, the upstream device reduces the traffic rate for tenant 1's queue and caches the traffic locally. If the upstream device's buffer also exceeds the backpressure threshold, it also sends backpressure packets to its upstream device, achieving cascading rate reduction and tiered buffering. When traffic bursts occur for tenant 1, only tenant 1's burst traffic triggers the backpressure process, with other tenants' traffic remaining unaffected. Huawei's SPFC technology achieves precise flow-level control, ensuring zero packet loss over distances of thousands of kilometers and lossless long-distance RDMA transmission. In scenarios involving local storage and remote computing, SPFC works alongside Huawei's adaptive flow repathing technology to achieve 97% computing efficiency, ensuring high training efficiency for AI foundation models.